How you doing? I'm Plasma. Today's video is called DARPA Documents and Patents. Have we engaged the Borg? Now this is going to be a bit of a strange video and not a video that I thought I'd ever be making in my life, but here we are. I'm going to go through some documents and stuff now, and it's up to you to decide what to make of it. It seems pretty strange, it seems pretty bizarre, so I'm not going to say it's 100%. I'm just going to say it's a very, 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 very weird parallel. So if you don't know the background of who the Borg are they're called the Collective, the Borg Collective, and they are a symbiotic with technology species from Star Trek The Next Generation. They all belong to this thing called the Collective, which is the hive mind, which is all ran through an electronic signal all throughout the Borg species. It's kind of a combination between artificial intelligence and humanity, all with the purpose of just assimilating other technology and other life forms in order to bring it into its own collective. They were the most terrifying enemy I think I've ever seen in any type of science fiction or any type of fiction, actually. I think I was absolutely terrified of these creatures when I was a kid, because I saw it in Star Trek when it first came out. The reason I'm stating this is because, well, quite a few reasons actually. Everything I say is scientifically verifiable, and I will take you through what I found. I wasn't aiming for this conclusion. This conclusion happened upon itself, and I didn't have to make any jumps for it either. It is what it is. It's very strange. So let me go into it and I'll explain my way of explaining it and the way that I've thought about things and then how it suddenly appeared to me. So let's get started. First off, I began by researching what people have been saying was on these swabs that people are inserting nasopharyngally for the purpose of the RRT-PCR tests, which do not work. And this guy in Slovakia ran it through a high-powered microscope, and he found that there were these crystals that were growing, sorry, not crystals, little particles that were on the end of these swabs that are inserted into the nasal cavity. And they ran a test when they rubbed it onto a raw steak, and they found that these little shards detached themselves from the edge of from the tip of the testing swab, and they aligned themselves in a vertical method once they were put onto the steak. They also ran the crystals underneath a microscope, and once they introduced human saliva into the equation, they found that the crystals, which they have identified as hydrogel, which is a patent from DARPA, it starts to become a crystalline lattice structure under saliva in the microscope. I have a picture of it here from their experiments. So this is what happens to the material that comes off the swabs that are used for testing. It's different to the worm-like structures which you get onto the masks, which I'm going to go into in a second. I've found out a lot of stuff about that stuff as well. So this is what happens when the hydrogel from DARPA's patent is added to bodily fluids, mucus, etc. It starts to form this crystalline lattice structure, which if you look at the shapes of it in the patent, it's very, very purposeful and very, very crystalline. It's a crystalline lattice structure. So it's stated in this article that I have here that this person had wrote defining what this stuff is, and it stated quite a few times that DARPA had these patents regarding the DARPA hydrogel. It said they grow in a fractal manner as well, which I thought was quite interesting. But it didn't name any of the patents in the paper that this person had published. The name of this paper is The Analysis of Stick Tests from Surface Testing in the Slovak Republic. This shows the spawning methods of this material that is collected, and the DARPA hydrogen content balls, which disconnect from the end of the swab and plant themselves onto the top parts of your nasal cavities. So I couldn't find the patent that the guy was talking about in this paper. So I loaded up DuckDuckGo and did a bit of searching, and I started going through the DARPA patents. And what I found that were connected to all three was quite astonishing, to be honest, and it's kind of led me down this path that I've found now. I'll load this up. So I found these patents assigned to DARPA. There we go. So I tried to figure out what would be the purpose of adding the hydrogel crystals to a nasal swab. And the conclusions I'm coming towards are quite strange, but I'll just list them as I go. So these three I found that could be possibly related. The first one that comes up is an environmental control of liquid-cooled electronics. Here's the abstract of the patent. A system and computer program product are provided for controlling liquid-cooled electronics, which includes measuring a first set point temperature, TA, wherein a TA is based on a dew point temperature, TDP of a computer room. A second set point temperature, TB, that's the secondary, so two separate measurements which you use in thermionics, is measured, wherein the TB is based on a facility chilled liquid inlet temperature, TCI, and a rack power, PRAC, of an electronics rack. A modular cooling unit, MCU, set point temperature is selected. Now, what I'm looking at from this is what is the purpose of chilling these so-called mRNA vaccines, or experimental chemical agents, whatever you want to call them, really. There's a purpose behind that, but maybe there isn't, so I didn't want to jump ahead of myself anywhere else then. So let's get back to the crystals. I started to think, what was the purpose of having a hydrogel that would be added to your brain? And that's when I saw this patent, which was granted in May the 22nd of 2006 by Chaobin Mao, Shan Tang, and Sanjay Banjari. Here's the abstract. Nanoparticles in a flash memory using chaperoning proteins. Patent number 8709892. Here's the abstract. A method for fabricating a flash memory device where the flash memory devices include a substantially uniform size and spatial distribution of nanoparticles on a tunnel oxide layer to form a floating gate. The flash memory device may be fabricated by defining active areas in a substrate and forming an oxide layer on the substrate. A self-assembled protein lattice may be formed on top of the oxide layer, where the self-assembled protein lattice includes a plurality of molecular chaperones. The cavities of the chaperones may provide confined spaces where nanocrystals can be trapped, thereby forming an ordered nanocrystal lattice. A substantially uniform distribution of nanocrystals may be formed on the oxide layer upon removal of the self-assembled protein lattice, such as through high temperature annealing. Now, when I click further into this to find out what it's about, this government sponsored, it gives you a quick background information, so I will explain that then. The background information of this invention. With the increased complexity of electronic systems in the future, there is an urgent demand for high density, low cost, low power and high speed semiconductor memories, such as flash memory. Flash memory may refer to rewritable memory chips that hold their content without power. An example of flash memory used to address the need for high density, low cost, low power and high speed semiconductor memories is an electrical erasable and programmable read-only memory, EEPROM. However, EEPROMs have large write-erase read times in comparison to other types of semiconductor memories. Write-erase read times in EEPROMs may be improved by using what is known as quantum dots, or nanocrystals, embedded between the control oxide and the tunnel oxide in the flash memory. A quantum dot may refer to a small nanoparticle that contains a few electrons. These embedded quantum dots act as a floating gate and may improve the erase right read speed. Further, these embedded quantum dots or nanocrystals may improve the non-volatile charge retention times due to the effects of Coulomb blockade, quantum confinement, and reduction of charge leakage from weak spots in the tunnel oxide. Other areas of improvement include device scaling, operating power, and device lifetime. There have been several methods used in embedding nanocrystals, including aerosol deposition, direct chemical vapor deposition (CVD) growth, and precipitation methods that use ion implantation and the deposition of psi-rich oxide layers, that's silicon. In each of these methods, the nanocrystal size and position distribution cannot be controlled. By not being able to control the size and spatial distribution of the nanocrystals between the control oxide and the tunnel oxide, the device performance, scalability, and manufacturability may be limited. Therefore, there is a need in the art for a more uniform size and spatial distribution of the nanoparticles between the control oxide and the tunnel oxide. Now, what this means is they have created and patented a method to use silicon-style nanoparticles for the creation of crystalline lattice structures for the sake of creating micro-sized, built from nanopart-sized EEPROMs or flash drives. Memory. It's like your motherboard on your computer has the BIOS of its system, and that's called your EEPROM. That's the main computing system. It hasn't got a massive amount of data, but, well, some of the new ones, mine has 256 megabytes. That's a lot of data for a motherboard drive, because that's what converts machine code to computer code. So it's the main hub drive of it. It'll use systems like ASCII or binary systems to run it from. So they found a method of creating a data and information storage method from nanoscale built up to microscale through the containment of data within a nanocrystalline lattice structure, which can be forwarded from silicons. Hydrogel. Yeah. The next patent I come across is something else that I think is important towards this field. It may come with what's going on with those, what looks like moving structures within the so-called vaccine or experimental chemical agent. This is in vitro metabolic engineering on microscale devices. Patent number 7427497. The abstract. Disclosed herein is a microfluidics device that can be used to prepare natural products and their analogues. The device comprises the enzymes of a biosynthetic pathway immobilized thereon and a means for sequentially directing a starting material for each ensuing reaction product to the enzymes of the biosynthetic pathway in the order corresponding to the steps of the biosynthetic pathway. The device can thus be used to prepare the natural product using the natural starting material of the biosynthetic pathway or analogues of the natural product using an unnatural starting material. Alternatively, artificial pathways can be created by immobilizing an appropriate selection of enzymes on the device in an order whereby each subsequent enzyme can catalyze a reaction with the product of their prior enzyme. Novel chemical entities can be prepared from these artificial pathways. That was in 2008. Polytechnic Institute of DARPA, or Rensselaer. Now, what this means, after I read the patent that was granted, its uses and its background, it talks about the ability to add polymers to inside biological cells by creating a tunneling gateway in order to introduce a secondary chemical which the body thus would not then eject. When you go further into the patent, it talks about the chemical structures of compounds using covalent bonding. Now, what covalent bonding is, it's when, see in chemistry, when you have different particles from the elementary table, the periodic table of the elements, each shell runs by something called the octet rule, and that means it'll be a multiple of 8 or a series of 8. So it's normally 2, 4, 8, 16, 32, etc. and so on, and they're called shells. Now, in order for a shell to be complete, to be chemically bonded, you have, for example, very, very strong structures on the electron level. You'll have H2O. What that means is there's 2 valence shells on a hydrogen atom, and that's bonded with oxygen. That gives you water. And if you look at the electron status and the amount of protons and electrons of a oxygen shell, you'll see that it has 6 electrons free in its outer shell that are rotating around the atom itself. Now, in order for it to be a complete atom, for it to actually exist, which is why it's rare you'll ever find oxygen on its own, it's always bonded with something else. And what it seeks to do is bond with another 2 electrons from a different chemical in order to make a complete structure. That's why we have water. So hydrogen has 2 spare electrons in its orbital, and that will join with oxygen, which gives you H2O, which is a perfect 8 on its outer shell. That's how you get it together. Now, this pattern talks about leaving shells open once it's been inserted into the cell. Now, what this means is you could introduce, as long as you leave those electron gaps at the end of the chemical equation that you've created, or the other bonding of chemicals, you could, for instance, add lithium or something else, because you could specifically target whatever this chemical that you're introducing into the system by adding that extra couple of chemicals, and it could be a time delay until this certain thing it's a catalyst, and then it will become a compound, but it could be completely inert till it becomes a compound. Anyway, that's the background there. Then I found this. This is a patent from, it's a presentation from DARPA. It's a talk called, and this was given to somebody from a Freedom of Information Act in 2006. Now remember, we just saw the patent of the crystalline lattice structure from hydrogel of 2006. Now this slideshow from within DARPA is called Micro Air Vehicles Special Challenges by Jim McMichael at the Georgia Tech Research Institute, Georgia. Presented at the DARPA Airplane on a Chip workshop in Arlington, Virginia, 20th of the 6th, 2006. Now here's where it started to get a bit creepy. Well, a bit creepy. It's all creepy. I found this slide called The Insect on a Chip. So they started to look at the different possibilities of using different creatures instead of just using aircraft that they've created themselves. But they found that they couldn't use insects directly because they have such pesky things as unpredictability due to things like temperature, wind, humidity, mating, and feeding, etc. And the insight they found of correcting this problem of them being, individualistic thinking creatures is the insight, and the solution is to eliminate unnecessary biology using MEMS. MEMS is microelectronic microprocessing chips. They're absolutely tiny. It's the next generation of electronics. And the next part now, it comes into, which I saw, which I really didn't expect, was insect cyborgs. Now it turns out they started creating this in the 1940s. You can see here that there's a moth pupa that was halved, and what they did was they sectioned the pupa of a moth with a small acrylic pipe for hormone transport for it to be split in half, and then they inserted a ball bearing into the tube itself, and in order for a fluid to distribute between the two, and the ball bearing would stop as a ball valve gap check, which means that no growth could go from the different parts of the body from the top section of the moth to the other. So it's blocking certain types of hormones and electricals. This is the first time they found out they could actually manipulate species by messing with the absolute bodies of it, and this was in 1942 they were doing this. And they started adding platforms of silicon chips. They started adding to the pupae balsa platforms. They inserted different platforms of engineering into the creature, and they found that we have proven successful platform insertion into pupa stage without affecting flight or lifetime, and it's ready for locomotion and control payloads. Now here's the next part. Hybrid insect MEMS. What they added into this creature was ultrasonic transducers. That's a transducer is it's a high-powered emitter on a micro scale that sends an electromagnetic wave. They have piezoelectric flaps for power. So this is a half electronic, half real creature. They have pheromone ejectors from the actual creature itself. They added a light source MEMS, which is a very, very, very small type of next generation technology, onto this creature. They have tissue anchors, and they added a cross insert into the pupae, and they have neutral muscle probes, which will give it extra increased strength. Now, here's the thing that has really stood out to me when I was looking at this. You see here, there's the thermoelectric power flexible platform, and this is on a micro and nano scale. See this little wire here? Now what this reminds me of is this. This is called a Peltier unit, or a thermoelectric generator, a TEC or a TEG you could call it, that goes either way as long as you add a blocking diode. Now the way that this works is you have two different types of metal on one side, and one side you have one, and say imagine copper or something, and on the other side you might have iron, or it could be any other material really, or graphite or something, but metals generally tend to work best. It could be zinc or something like that. Now different types of metal have different levels of resistivity, and as well as different conduction methods. Now what happens when you put two different types of metal together and you add different temperature coefficients to each side? So imagine delta T hot on one side, which means the change in temperature of hot on this side, and you have a delta TC on this side, which is the change in temperature of cold. So what happens when these two metal plates are touching? The electrons between the two different formats of metal, they will start interacting to each other, and that's called thermionics. And this is thermoelectric generation. So what happens then, the electrons start to excite themselves between the two different variances of metal, and this generates a solid state form of electricity. The very first formats of thermometers actually were called thermocouples, and a thermocouple means it's the coupling, the joining of two different metals. So the first thermometers were actually things like aluminium and copper, and then when you add a certain amount of heat, it would bend a certain way. And then the degree of it bending is the way that you could detect what the temperature of something is. They use them in ceramics as well with cones. It's quite a similar thing, theory, before they had high level temperature technology to detect. So it's the exact same purpose. So this would be how it gains its power. It would be by using a thermally conductive variable coefficient between two different types of metal. And of course, you can see this little line there with the little spikes. So that would be copper on a different grounded format. And then you would see it curl or increase or possibly coil. And this is how it would be transferring its information. So then I thought, okay, I've seen something like this before with that little thread there. And I thought, what else looks like that? And of course, this brings us back to the mask worms, doesn't it? So I loaded up the best high definition microscope video I could find of what these fibers were, and I thought as long as we can get more zoomed into what these black fibers are, we could find out what they are by looking at their composition. So if they were all a solid black, it might tell us that they're an all carbon material, or if they're all when it's even more zoomed in, if they have say greens or things like that, we might find out that it leans more towards the biological aspect. But then I thought, okay, if this has two different types of colouring, it may work the same as the thermocoupling I've just explained. And then I looked at and I found a video, and here we are. This is one of the fibres under a microscope. And of course, one of the most conductive substances on Earth for thermionics is copper. And to me, that looks like a one-sided copper and a one side of carbon. Power. It's a power system. Maybe. So then I went back to the PDF again, thinking, okay, that's pretty strange. That's interesting. And I read further. They've got quite far with where they have gone with this technology. I'll put the link to it down below. The 1950s, they've been working on MEMS quite a long scale for. They've now managed to scale down to chip scale size atomic clocks, which was previously one of the highest reaches they were gaining for. And you can see that the hybrid insect MEMS come out around 2000. They're saying it's a very messy technology though, and they're trying to improve its reliability, but they have now managed to super scale it and downsize it as well at the same time. Now, as I was scrolling through this paper, it goes back more into the background of insect metamorphosis, of how the implantation is done and other methods of introducing cybernetics into moths, because they found that they were the most easy to adapt because they can have the pupae which they can work on. I carried on scrolling through this, and eventually I come across this. This is the scale of MEMS technology. It's the micro platform inserted into moths. There's the size of it with a quarter. It shows the X-ray images here in this image, and then I found this group. This was a project run by the Boyce Thompson Institute, and the project was called Insect Sentinels. So they're creating cybernetic, remotely controlled insects they call sentinels, which can be controlled remotely, and using them as MEM systems for far away operation, and using them for payload delivery as well as complete control by taking over their main subsystems of their brain. So I looked into who the Boyce Thompson Institute were. Clicked through a few pages, but I didn't have to go far at all. Like I said, I have not made any jumps in anything I'm saying here. It's literally one click and then you're there. Click that off. So I typed in I typed in the Boyce Thompson Institute to find out who these guys were, to find out if I could see anything more about the insect sentinels. And as I said, I wasn't expecting to go anywhere with this. I wasn't expecting what I found, so I wasn't looking directly into something. This literally it's the first things I see when I was researching it, so I didn't even have to dig far. It's kind of the first things that come up. It's not outlandish or out there, it's the first things you see from their words. So I went to the page of the Boyce Thompson Institute of Insect Sentinels, and this place popped up. I went to their homepage, and I was wondering, I wonder if I could find out about this group and what's the technology they've been involved in. And of course, you scroll down, and this is a group that you think would be studying insect viruses at the Boyce Thompson Institute, as well as finding out how to robotically control them. They began creating a technology transfer to improve agriculture, to enhance human health, and to protect the environment. We've heard that before. And what's the first discovery they've made, making an impact? Vaccines and other protein production in insect cell lines. And plant-based vaccines. Plant and bacterial proteins in innate and effector-triggered immunity. Okay. I didn't read this before either. I never saw that. I'm seeing this live. Today you can find the high 5 cell line in the Thermo Fisher scientific catalogue. Now, of course, if you remember who Thermo Fisher are, the Thermo Fisher 7500 is the same machine that runs the RRT PCR tests. I've only just saw that. That's okay. So then I started thinking, okay, we have crystalline lattice structure, which can be used to store information, much like in the way of an EEPROM. We have thermoelectric power distribution system, much like the Peltier-Seebeck units, or TEC or TEG. And what are the other components that are here? And then I thought, okay, let's start looking at this like a computer, and let's start looking at it like code, because everything is a code, right? Everything is programmable. So I made a slideshow, and I thought what I could do is explain some comparisons between the human body and between a computing system that everyone would be able to understand. So I made this slideshow. I don't know how to reset that. How do I reset that? Oops. Oh, there we are. Okay. How do I reset that? properties. I should have just uploaded all of them. Okay, so you have. Oops. This is what happens when I do it live. Is there no click button? No. Okay, so first off, we start with a motherboard, a CPU, and an EEPROM. So on your computer, you have your main motherboard, you have your central processing unit, and you have your EEPROM, which is electronically engineered processing setting. I can't remember the exact statement for what an EEPROM is, but it's the way that you classify the BIOS or rewriting the stamp of the actual system for it to understand the next stage of machine code to computer variant. It's where you write the main status and stamp of what the whole process of what the electronic parts are going to do and which way and channels the electrons will move in according to fulfill its protocol of transferring from machine language to computer language. Now, in order to retain this data, it has to have a coin cell battery. So before you even use the power from your wall, it has to retain this information that's wrote on the stamp BIOS. And in order for it to maintain that, it has to have this little coin cell. You can use high power capacitors now or things like that. That will also keep the memory alive on the motherboard. This is essential in order to contain that transferable machine code to computer language information. So it has to have that power source. Now what I see here is the coin cell battery. If you're thinking of it as a human body, if the motherboard is a human body, the coin cell battery in your way your body currently is, from what your currently wrote BIOS is, food would normally be your energy in order to create the kilojoules of information in order to store what you have here in order for you to be able to perceive the world for what it is. You're constantly maintained by the change of food energy into body and electrical energy, which is then created by your brain. That's what keeps your information up there. So that's your BIOS, what's already stamped onto there. Now what I've done here is I've compared the motherboard with the human body, the CPU is with your brain, and the EEPROM from your motherboard, you might as well class that as given to you as divine methods, the spirit, the soul, etc. It's your original born programming, it's your system, and it's what you were given by the universe. So those are both analogous. So then what you can do when you're comparing them both is with the computer, that's reflashable. And I suppose when it comes to the human brain, it would be reflashable as well. And here's how you would rewrite it with the computer. On the EEPROM BIOS, if you ever reflash your motherboard, you would do it with a USB stick, or you can do an OTA update, which is over the air. So you could use a LAN cable or Wi-Fi, and you can do an over-the-air update. Say if you have to rewrite the motherboards for 10,000 computers for a major company like HP or something like that, or Intel, you won't go around and do it one by one with the USB. You will do an OTA update, which is over the air. So I think you know where I'm going with this. So if you compare the analogous to your body, you eventually get this. The crystalline lattice from the hydrogel is uniquely similar to that EEPROM chip you see on a motherboard. The thermoelectric strands that you see, that's quite analog to the coin cell that you see on a motherboard. And your vaccine is quite similar to a BIOS reflasher. I don't think that's quite a jump. I think it's a very, very close jump, to be honest. It didn't take me long to get there. But of course, you could do it over the air. And a 5G signal is just about right for that antenna spectrum. If you use the antenna equation of C equals F by lambda, which is the speed of light is equal to the frequency of a wave multiplied by its wavelength, that's called the antenna equation or the wave equation. And from that, you could use it to detect an electromagnetic wave that's sent out in the air. Now, the antenna size of something, the smaller it is, the higher the frequency. So if you're going to program something nano, you're going to have a very high frequency antenna. Um, so this could be a bit out there or whatever else. Um, but something I did find interesting was this. Sorry, I have to forgot to load this up, and I tend to film in one go, so and I don't write scripts, so um, let me just find this. Yeah, so I found these and thought to myself, there's the Operation Warp Speed logo, and I thought, you know, it looks quite similar to that. Let's pull that out there. Borg ship. Yeah. Anyway, I was Plasma. Take it easy.